Welcome to Module 3. So this week start out with hypothesis testing, which is the bulk of the rest of the course. There's a lot of information to cover, so I recommend that you take the time to go through the steps to understand the flow of hypothesis testing. There's a lot to do, but I hope I laid it out the process in a logical way. So once you follow it and if you practice it a few times, it's not too bad. There are a lot of pieces in there, so I'm gonna go through all pieces in sequence. And of course, you can use a spreadsheet to help with your calculations. So what is a hypothesis? It is essentially just a claim or assumption about a population. And we're going to be looking at the parameters that we've been studying, so the proportion, the mean, and the standard deviation. So for example, a doctor claims that 17-year-olds have an average body temperature that is higher than the commonly accepted average human temperature of 98.6 degrees Fahrenheit. So the key word here is that the statement here says something about the claim. So if you see the word claim or test a claim or something like that, you're doing hypothesis testing, which is the procedure for testing the claim about the population parameter. So there are 8 steps to testing the hypothesis, which is outlined in your lecture notes. So we'll cover all these steps and we'll do it in sequence. So there are a lot to do and there are a lot of things behind the scenes, but my goal here is for you to understand each step so you can get to the making the decision and then stating the claim or making a conclusion out of that. So the first thing is you identify the claim to be tested and give the expression in a symbolic form, which I'll cover in just a little bit. And identify the null and alternative hypothesis, select the significance level, identify the test statistic and determine its sample and distribution. Find the value of this test statistic and use the method that we're going to be new method we're going to be learning, which is the p-value method or the critical value method in order to make a decision, which is step 7. And by make a decision, what I mean by that is reject the HO, which is a null hypothesis, or you fail to reject the null hypothesis. And once you do that, the next step is to restate the decision. So basically you say, okay, what's your decision? Reject the null hypothesis or not reject the null hypothesis? What does that mean in terms of the problem? And we will learn to state the conclusion in non-technical terms. So the first thing you have to be able to understand is to identify the null and alternative hypothesis, which is right here. The null hypothesis is denoted by H0. It's a statement of the value about the proportion that is equal to some claimed value. So the key for the null hypothesis is that it's equal to some value, proportion, mean, or standard deviation. Okay, and then at the end we are going to either reject the null hypothesis or not reject the null hypothesis. That's how you write it, HO or not reject HO. Or H0. The alternative hypothesis is obviously alternative to the null hypothesis, and it's somehow different from the null hypothesis. So for the key thing about the alternative hypothesis is that it has a symbol less than, greater than, oh, that's a typo in there. It's a not equal to. So if you see less than, greater than, not equal to, that's the alternative hypothesis. So instead of going through these steps in my lecture notes, I created the PDF, which is in my website. So I recommend you download it and take the time to read this through before you attempt to do the calculations, because if you just jump into the calculations, they won't make any sense. So let me do part 1 of the hypothesis testing. So we're going to be looking at 3 types of testing. One is for the proportion, one for the about a mean, and one for the standard deviation. So these are the parameters we'll be looking at. But first, let's cover the basics of hypothesis testing. Okay. So these are the key concepts you should know. We're going to learn how to identify null hypothesis and alternative hypothesis. We're going to calculate the value of a test statistic and use that to as part of it to make a decision later on. And we'll use a method called the p-value method or a critical value method to make a decision, and we'll state the conclusion. Okay, so we covered the definitions. Here's a null hypothesis again. Again, the key thing is equal to. The alternative is less than or greater than or not equal to. And the alternative hypothesis either denoted by H1 or HA. Okay. And so here's an example. Assume there are 100 babies who are born to 100 couples and treated with the XOR, some kind of method of gender selection that is claimed to make baby girls more likely. We look at 58 girls in 100 babies, write the hypotheses to test the claim that with the XOR method, the proportion of girls is greater than the 50% that occurs without any treatment. So in this case, the null hypothesis is the claim without the test or without this method is that the proportion of the girls, so P in this case, is going to be equal to 50%. So how did I know it's 50%? It's not explicit in the problem. Well, it's just a known fact. Without any gender method, selection method, the proportion of boys and girls will be 50-50. So that's how I knew it to be 50%. Alternatively, with the XOR method, the claim is that the proportion of girls, so let's say this P stands for the proportion of girls, it's going to be greater than 50%, so the greater than sign. I knew it's going to be greater than sign here because the problem says greater than 50%. So that's how I knew to use a greater than sign here. If the problem had said less than here, then it will be less than here. And if the problem had said the proportion of girls is not 50%, it doesn't say greater or less than, then this will be not equal to. So that's how I know which symbol to use down here. Okay. We'll select the significance level, which typically will be given to you. It's going to be 0.05 or 0.01. We'll use that value a little bit later on in the p-value method. So it's going to be either 0.05 or 0.01. If it's not given to you, if the significance level, which is denoted by this letter alpha, Greek letter alpha, you can assume the alpha value is 0.05. Okay, but typically it's given to you. Okay. Oh, so the more common values are 0.05, 0.01, or sometimes 0.10. All right, now we identified the test statistic. We call it test statistic because we use that statistic, meaning proportion, the mean, standard deviation, or variance, to test the claim. So that's why it's called a test statistic, and it has a specific letter for each test we're going to be looking at. So for the proportion, we'll be using Z. If it's mean, if we're doing a hypothesis test about the mean, we use T. Sometimes we can use Z. I'll cover that in a little bit. If we're doing a hypothesis test about the standard deviation or the variance, we use the test statistic chi-squared. So we've seen all these before, Z, T, or chi-squared from last week. So these are the test statistics we're going to be using. Okay, so this is what that test statistic is. All right, then we use p-value method or critical value method to make a decision, which is easier to see in the spreadsheet, so I'll do that a little bit later. Okay, so we're going to continue on with the spreadsheet. Okay, so another thing we're going to be looking at is there are three types of hypothesis tests. One is called a two-tailed, one is called left tail, one is called a right tail, and I'll show you what these are in the spreadsheet. So, but remember there are three types, and you have to determine whether it's two-tail, left tail, or right tail when you continue with your testing. Okay. So p-value method, and I'm gonna be skipping these because you can read those on your own. So let's see what else is there to cover. Okay. All right, so I'm going to move on to the spreadsheet to show you how to do hypothesis testing with the proportion. All right. Let's see if there's more. Okay. So going to my spreadsheet. So here's just a quick overview of what I just covered. Okay. So I mentioned that there's two left tail, right tail, and two tail test. Well, this is the picture for a normal distribution. It's a bell curve. This little area over here, down here, it's called a tail. That's what the word tail comes from. It looks like a little tail, and the region in this area here, it's called the left tail. And region over here is called the right tail. It's called the right tail, left tail because obviously it's on the left side and the right side. But if you look at the bottom here, this bottom line, it's called the number line. And if you remember from algebra, the number line, it's defined so that if you go to the right, it's greater. If you go to the left side, it's smaller or less than. So left tail is associated with the less than, and then the right tail is associated with the greater than. So keep that in mind when we do the hypothesis testing. So here's an example. I'm going to start with the hypothesis testing for proportion. And we'll do this slowly so that you understand all the steps. So again, it's the same problem that we saw in the PDF. And I'm highlighting the word greater than because it's going to be a one-tail test. Okay. So we already stated that now it's going to be 50%. And then the greater than, the alternative would be greater because the word says greater. Okay, so that's how I know it's going to be a greater sign here. That makes it a one-tail test, and moreover, this word makes the whole problem a right-tail problem because I mentioned it's greater than to the right, so it's going to be right tail. So for you to use this spreadsheet, here's something to keep in mind. This spreadsheet, Module 3 spreadsheet, will do hypothesis testing for proportion, the mean, and then the standard deviation. So the claim about the proportion, the mean, the standard deviation, it's all covered in this spreadsheet. In addition to that, this spreadsheet will cover the left tail scenario, right tail scenario, and two tail scenario. So your job is to find the right section, right tab, and then follow the right section for the right tail, left tail, and then two tail. They're all separated. So to begin, this one is a right tail example because it says it's greater than. And I know this is a hypothesis testing problem because it says test the claim. As I mentioned, if you see the word test the claim, that's a key phrase for you to do all hypothesis testing. Okay. Another thing you notice is that the alpha is set to 0.05, so that's the significance level. All right, so keep that in mind. So I stated the null hypothesis and alternative hypothesis. So the next thing is, which test statistic do I calculate? Which one do I choose? So the proportion, I mentioned that here's a table that you saw earlier. So for the proportion, I'm going to calculate the z-value because that's the test statistic I'm going to be using for proportion. And to calculate the test statistic, this is the formula here. P hat minus P divided by square root of PQ over M. Okay. Again, we don't do this by hand. We'll use this spreadsheet to do so. So I have done the spreadsheet calculator for you right here. And so all this is coming from previous module, module 2. We already know how to calculate the z-value. So to calculate this, you need four things: p hat, p, q, and then n. So that's how I have it listed here. Okay. So I have n, which was 100 babies. In order to calculate the p hat, you know from last week that it's going to be x over n, so that's why you need x and n here. So that calculates the p hat. So p hat is the one you calculate. So that's one thing that people get wrong, is confused about, is that what's the difference between p hat and then the p? P hat is the observed number, so meaning that's the number you had to manually calculate from the problem. So in this case, 58%, 58 divided by 100. P, not the p hat, is the historical or given value. So in this case, historically, the babies, without any gender selection method, you know that it's going to be 50-50. So that's how I knew to be 50% here. So be careful which one is p hat and then p. And if you have any questions about that, let me know. I'll try to explain that again. But again, p hat is the one you manually calculate from the problem. P hat is the historical number, or somebody tells you the p is 50% or whatever. Then you put that number down here. So if you put all these numbers down in this section, it'll automatically calculate the test statistic following this formula here. Now, we're doing the p-value method in order to make a determination as to whether you reject the null hypothesis or not reject the null hypothesis. So this section calculates the p-value, which in this case is 0.0548. So once you calculate the p-value, you have to make a decision. So how do you do that? Well, here's the rule for p-value method. The rule is, and I recommend you remember this, is that if the p-value less than the alpha, given the alpha, then the rule is you reject the null hypothesis. Okay, so the p-value is less than alpha, you reject the null hypothesis. Otherwise, you do not reject the null hypothesis. Okay. P-value is less than alpha, reject the null hypothesis. Otherwise, don't reject. All right. So let's look at this p-value, 0.0548. Is that bigger or smaller than alpha, 0.05? Okay, so that's what you have to determine. So in this case, the p-value is 0.0548 is bigger than 0.05. It's very close, but p-value is bigger. So following the rule, here's the first step of the conclusion. Since the p-value is 0.05, we failed to reject the null hypothesis. We cannot reject the null hypothesis. Okay, so that's the first part of the conclusion. Second part of the conclusion you will need to include in your assignment or the quiz is the second part here. So what does that mean in terms of the problem? For this particular problem, that means for the XOR method, or baby gender test, there's not sufficient evidence to support the claim that the XOR method is ineffective in increasing the probability that the baby girl will be born. Okay, that's a mouthful. I understand that. But you can think of this as like you're arguing in court. Okay? We cannot be 100% certain, but the evidence says that XOR method doesn't work. Okay? That's what this means. And if you go to my week 3 or module 3 folder, there's a document that tells you how to word this. So I recommend you look at it and practice writing it down. Okay? So your conclusion has to be consistent. If you reject the null hypothesis, what does that mean? Or I mean, you're not rejecting the null hypothesis. Okay? Meaning that I'm not rejecting this. I'm going with this. So that means XOR method doesn't make any difference as to the proportion of baby girls born, because I'm going with this, not with this. Okay? So practice with that, and make sure when there's a question that says write down the conclusion, you include two parts. This part where rejecting or not rejecting null hypothesis based on the p-value method or the critical value method we're going to cover a little bit later. And the second part is, what does that mean in terms of the problem? So state those two things to get full credit for your conclusion. All right. So once you understand the process, the rest is going to be easy because it's pretty much the same. So I'm going to show you the left tail example. It's the exact same problem, except this time the problem states that the proportion of girls is less than 50%. Okay, so that means it's less than, so the sign's less than, which makes this a left tail problem. Okay. Everything is the same up until here, except the p-value method is different. So the p-value calculation is different between the right tail and the left tail. If you want to know the details, you can click on the cell to see the differences, but you just know to use the right cell for p-value. Okay. So p-value for this one is 0.9452. Again, it's greater than the alpha value, so the conclusion is the same as before. All right, so you've seen the left tail example, right tail example. Now you know how to differentiate between the two. If it says problem is greater than or more than or bigger than, anything like that, that's a right tail problem. If the problem says less than, at most, or smaller than, whatever that is, then the problem is a left tail problem. So when is it when it's a two tail problem? Okay. It's a two tail because from the problem we cannot tell whether we're looking at left side or right side. So to cover our bases, we're gonna look at both of them, this side and this side together, two tail. That's why it's called a two tail. So let's look at the example. In a sample of 100 M&Ms, it is found that the 8% are brown. Use a 0.01 significance level to test the claim that the Mars company or Mars candy company that the percentage of brown M&Ms is equal to 11%. Okay? I know this is going to be a hypothesis testing problem because I'm going to be testing the claim. Okay? And I cannot tell if it's a left tail or a right tail because it doesn't say less than 11%, greater than 11%. It says equal to. In other words, it could be equal to or not equal to. Okay? So, the null hypothesis is that the 11% is the brown M&Ms. And the alternative is not equal to 11%. So in order to do not equal to sign, you can either do equal sign with a slash, or if you don't know how to do that, you can put explanation point and equal sign. That's the same as not equal to. So if you don't know how to do not equal to sign, just write down exclamation point equal sign, and that's the same as not equal to. Okay, so again, same thing. I need to calculate the test statistic. Same thing. I'm doing the formula here. This thing. It calculates this. Okay, so it calculates one tail, but I mentioned that we're going to be looking at two tails, both tails. So because the normal distribution is symmetrical, we can just double this tail. Okay, so one tail is 0.068. Double that to make it 0.137. That's your p-value. So again, if you look at it, it says it's bigger than 0.01. Oops, wrong one. 0.01. So again, we failed to reject the null hypothesis. One way to say is that there's not enough evidence to support the claim that the percentage of brown M&Ms is different from 11%. Okay, so we cannot reject the null hypothesis, meaning that we're going to go with the null hypothesis, meaning that percentage of brown M&Ms is equal to 11%. Alrighty. So if you read through the lecture notes, you're going to come across what we call the type 1 error and type 2 error, which is described in here. So I recommend you read about it, maybe in the book or in the lecture notes, to make sure you understand the differences between type 1 and type 2 error, because that's going to be asked in the assignment, I think. Okay, so let's just check that first. Let's see, is that okay? Maybe it's not in the assignment. Anyway, so read about type 1 and type 2 errors. Now, let's move on to testing the claim about the proportion or population mean with sigma unknown. Okay. That's typically the case because in the real world, it's very hard to know what sigma is. Okay. So this is most likely the case you're going to run into. And so this is a tab about the claim about the mean with unknown sigma. So just remember the notation, this means mu, which means the population mean, and then O with the little tail, it's sigma. That's the population standard deviation. So just know those two things because they're going to pop up. All right, so we looked at the one method to determine whether you reject the null hypothesis or not reject the null hypothesis. I'm going to introduce you to a second method, which is the critical value method. So here's how it works. Okay. So the claim, for example, the claim that for pulse rates of women is the average is 73, so the mu, population mean. The sample size is 40, and the test statistic is we calculate for you. Let's say its t is 2.463. Find the critical values for alpha of 0.05. So here are the steps. Okay, so since the claim is mu is equal to 73, this is a null hypothesis because remember, null hypothesis is always equal to some number. So this is a null hypothesis. So then your job is to figure out the alternative hypothesis. In this case, it's not 73. Okay, so that indicates a two-tailed test. So then your job is to figure out the corresponding critical values. Okay, and we did this in module 2 actually. And I don't have it open, so let me open it up. Okay, so open up module 2 spreadsheet. And you remember this critical value tab that I mentioned last week, and I mentioned that we'll be using this tab later again. So here we are. So here's how you find the critical values. So now you know what this two-tailed section is. So if you're doing a Z or T for two-tailed test, you use this section. If you're doing the right tail or left tail, so basically one tail, this is a section you use for Z or T. And later on, we're going to be looking at the chi-square. So for the chi-square, here's the two-tailed test. That's all we're going to look at. Oh, no, sorry. That's what we're going to look at. And then for the right tail, left tail for chi-square, it's down here. So make sure when you do the critical value method that you use the right section within module 2. Okay, here's two tail, one tail, two tail, one tail. All right, so going back here, if the sample size is 40, you see that, let's see, what was the problem? 0.05. So we're going to be looking at two tail and T, right? Yeah. So this value right here. Because we don't know sigma, you know that we have to use T. So then for critical value, it's going to be 2.02. And that's what I have over here. So now these critical values in the plus minus region, because it's two-tailed, it could be in the positive region or negative region. This determines the boundary for critical regions. So the critical regions is determined to be the outside interval between negative 2.023 to positive 2.23. So anything outside of that, it's considered to be rejection region. So in this case, the rejection region is somewhere t is less than negative 2.23 or greater than 2.23. So depending on what the t statistic you calculated, you look at the positive side or negative side. So since the t is t is positive, we look at the positive side. So is 2.463, is that in the rejection region or not rejection region? So it is in the rejection region because it's greater than 2.023. So that means we reject the null hypothesis because the test statistic falls in the rejection region. So that's how you determine whether or not you reject the null hypothesis using the critical value method. Okay. Visually speaking, if I can get to that picture right very fast, let's see. Here we go. So negative 2 here, positive 2. So if it's within this region, if the test statistic is in this region, you do not reject. But the outside, these are considered to be rejection regions. So since in the particular problem, the test statistic is in the rejection region, so that's why we reject the null hypothesis. Okay. So if you had to do critical value method, that's how you make a decision. Okay. So now let's look at the left tail, right tail, and two tail. Alrighty, so here's one example. Listed below are measured radiation emissions in watts per kilogram corresponding to a sample of cell phones. Use a 0.05 significance level to test the claim that the cell phones have a mean radiation level that is less than 1.00 watts per kilogram. Alright, a few things. You know it is a hypothesis testing problem because we're asked to test the claim. And I know this is going to be a mean problem because we're looking at the mean radiation. And lastly, I know it's going to be a left tail problem because we're testing the claim that is less than some kind of number. In this case, less than 1 watt per kilogram. So make sure you understand, okay, if I'm looking at this problem, it's a mean problem, left tail, hypothesis testing. Okay. So again, let's state the hypotheses, I guess. Null is equal to 1.00 watts per kilogram. The alternative is less than 1.00 watts per kilogram because that's what it says. So now, again, looking at the chart or this table, you see that if you're looking at the mean and we don't know sigma, and n is greater than 30, the test statistic we use is t. And the formula for that is this: x bar minus mu divided by s divided by square root of n. So you need four things: x bar, mu, s, and then n to calculate t. So that's what I have it over here. I need n, mu, x bar, and then s. So in this case, n, you just count how many there are. There are 11 of them. You know that t uses degrees of freedom, so that's 1 less than n, so that's 10. What's your mu? Again, that's the given number, so in this number is the mu. That's the claim we're looking at, so 1.00. What's the calculated x bar? So that's what this is the average of all these numbers. Okay. And s is standard deviation of all these things. We did that last week. So following the test statistic, this formula, this cell calculates the test statistic for you for left tail. And this calculates the p-value. And if you're curious, this is how you do it. All right, hopefully by now you're comfortable saying, oh, that's bigger than given alpha, which was 0.05. So I'm going to reject the null hypothesis. Or, sorry, we're not going to reject the null hypothesis. That means we conclude that there's not sufficient evidence to support the claim that the cell phones have a mean radiation level that is less than 1.00. Okay? We know at least it's going to be 1.00 based on evidence. How big, we don't know, but at least it's going to be more than 1.00. All right, so that's the left tail. Let's do the right tail, a very quick one. Assuming this information, the mu is 40, x bar is 172.55 pounds, standard deviation is 26 pounds, sigma is unknown. So boom, if the sigma is unknown, your only option is use t. Use the data to test the claim that the men have a mean weight greater than 166.3 pounds. Use alpha as 0.05. Okay. State the null hypothesis, alternative hypothesis, and these numbers. You will calculate the test statistic. These are all the same from last time, just above. And this will calculate the p-value for you. If you look at it, it has RT because it stands for right tail. Okay. Again, we failed to reject the null hypothesis, not enough evidence to support the claim that the men's population weight is greater than 166.3 pounds. Okay, so that's what I mean by give a conclusion. First part, second part. Alrighty, let's look at two-tail. Similar thing. Test the claim that the mean greenhouse emission of 8.00. Doesn't say anything about less than 8.00 tons, greater than 8.00 tons. It says equal to, or it's implied that it's equal to. So then the alternative would be not equal to. Okay, so do this, do all this, test statistic. This will calculate the p-value. Okay. You see ABS, that's the absolute value. I need to include that because this function t of this, that 2t assumes positive t value. Okay, so you don't, that's just a FYI. So again, we hope to see a problem where we actually reject something, but again, p-value is greater than alpha, so we failed to reject the null hypothesis. All right. So we learned about the critical value method, the p-value method, and the last method we're going to look at, it's called the confidence interval method. And before I get into that, I just want to let you know that unless the problem specifically says to use a certain method, so if the problem says to use critical value method, obviously you got to use this. If the problem says to use p-value method, you got to use that. But unless it says so, you can use any of these methods you like to make a decision. Okay, it really doesn't matter to me which one you use. So let me show you the confidence interval method. Obviously, it's going to be using confidence interval, but there's a little slight asterisk that I'm going to point out to you. Generally speaking, for the confidence interval method, for two-tail test with the 0.05 significance level, so for two-tail, you construct the 95% confidence interval. If it's a one-tail test with the 0.05 significance level, you construct the 90% confidence interval. So depending on the significance level and then whether it's a one-tail, two-tail test, you have to construct a different confidence level or confidence interval. And to do so, the summary is given to you in table 8-1. So keep this in mind when you do confidence interval method. I reproduce it over here. Okay. So if you're doing confidence interval method, you have to refer to this table in order to use the correct confidence level. So how do you do that? Let's look at this problem. Using a cell phone example, construct a confidence interval that can be used to test the claim that the mu is less than 1.00 watt per kilogram, assuming a 0.05 significance level. Okay. So let's use the confidence interval method because that's what it says. Okay. And the alpha is 0.05. So according to this, it's going to be one tail and then significance level of 0.05. So what is that? 0.05, one tail. So then we're going to be using a confidence level of 90%. You might think it's 95, but it's not. It's 90%. So make sure you use the correct confidence level. Okay. So again, all this come from module 2. And you calculate the confidence interval. So in this case, 0.707 to 1.169. So how do you use the confidence interval method? Okay, so here's how. If you use the confidence interval method, you have this confidence interval of between 0.707 to 1.169, which we saw last week. Because the value of mu of 1.00 is within this range, it's very likely that the true value of mu is within this range. So it makes sense that it's reasonable that 1.00 is the actual radiation level. So we cannot reject the null hypothesis that the mu is equal to 1.00 because 1.00 is within the interval. So we cannot throw that away. So we do not have sufficient evidence to support the claim that the mean radiation level is less than 1.00. Okay. As you noticed, between confidence interval method, the p-value method, and the critical value method, you should come to the same conclusion, meaning that between all of them, you will either reject or not reject the null hypothesis. You will not have a conflicting decision. So like one method tells you to reject and the other method will tell you to not reject. That will not happen except for the proportion. But just keep in mind that for you guys, the method should give you consistent results. So either all reject null hypothesis or not reject the null hypothesis. Just as a side note, it's possible to have that conflicting scenario if you look at the claim about the proportion, but let's not go there. Okay, so that's for the proportion. Or sorry, that's for the mean. Sigma unknown, because that's the most likely scenario. Key thing is use t. So let's look at the scenario where you do know the sigma. That's when you use z. Okay. Very unlikely. But if you had to do it, here's how you do it. Same thing. Test statistic requires z, so x bar, mu, sigma, and an n. So same situation, except that we know sigma. Let's just assume we know sigma to be 0.48. So that's what sigma going to be. Still calculate the x bar. Mu is still 1.00. N is going to be 11. So we have all the components to calculate z, which is this. And this spreadsheet will spit out the p-value for you, and same conclusion. Okay, we failed to reject the null hypothesis. So we looked at the proportion, the mean in both cases. So the last parameter we're going to be looking at is the standard deviation or the variance. Okay. So if you're looking at the claim about the population variance or standard deviation, here's the section you need to look at. So before I move on, let's just clarify one thing. So which test statistic do you use? I mentioned chi-squared. So we're going to be looking at chi-squared. Okay. So let's look at this. So consider the claim that supermodels have heights that have less variation than the heights of women in the general population. Let's use the significance level 0.01 to test the claim that the supermodels have heights with a standard deviation that is less than 2.6 inches. So I know it's the hypothesis testing problem because it says to test the claim. I know it's going to be a standard deviation problem because it says so in the problem. So be careful which table you're going to be using. It depends on the problem. So in this case, it's explicit standard deviation. You could say variance, either one. Just come here and use it. Okay. So the formula is, for chi-squared is this, n, s, and then sigma. Okay. So the claim is that the supermodels have standard deviation of height less than 2.6 inches. Okay. The null hypothesis, no, it's actually 2.6. So, oops. Let's figure out n, s, and sigma. N is going to be 10. There are 10 numbers here. Degrees of freedom is 9. What's s? Same thing as before. Standard deviation of all these. And sigma, what's sigma? That's given to you here. So that's 2.6. That goes in here. S is that you actually calculate. Again, just like p bar or p hat and p, be careful which one goes which. If you type in the right numbers here, you'll calculate the correct chi-squared. And this will calculate the p-value for you. Okay. Less than. So this example is for the left tail. If you're looking at the right tail problem, just change this cell to look like this. Use RT and then drop the true word true there to get the right tail p-value. Okay. Everything's the same, so I just got lazy and just this is the left tail. But if you got to do right tail, just make a change to look like this, and you get the right tail p-value. So finally, we have a situation where the p-value is way less than the given alpha, 0.002 or 0.002. That's less than 0.01. So there's sufficient evidence to support the claim that the supermodels have a standard deviation that is less than 2.6 inches. So that means what I'm saying is that because p-value is way less than significance level, I'm going to reject the null hypothesis and go with the alternative. And the alternative says the actual standard deviation is less than 2.6 inches. So that's what I'm going with. Okay. Instead of doing the p-value method for chi-squared, just use the confidence interval method. That's I'm going to show it to you right now. Okay. Same thing, except I'm going to be using critical value method. Again, we covered this in module 2. Okay, right here. And so this is the reproduction of that. Okay. So again, the key thing is to use a correct confidence confidence level. We're doing the one tail, and this alpha is 0.01. So according to table 8-1, here and then here. So the the confidence level should be 98%. That's what's entered here. So that's what I get 0.98 from. So if you do so, you get this confidence interval, which is 0.5 to 1.7. You notice that this interval does not include 2.6. It's smaller than 2.6. So that just adds credibility to the fact that sigma is less than 2.6 inches. Same conclusion as before. Okay. So let's look at the critical value method. Okay. So again, it calculates the chi-square. So let's calculate the chi-square. which was up here. Where'd it go? Here. We already calculated that. And the critical value method, you calculate it up here in the confidence interval method, because as part of the confidence interval method, you have to calculate the critical values to the left and to the right. So you make a comparison between, so depending on how big the test statistic is, you compare to the left side or to the right side. So this is small, 0.85. That's outside the interval between these two numbers. So this test statistic is in the rejection region. So I'm going to reject the null hypothesis, which is the consistent with the other conclusions. Okay. So no matter which method you use, you should come to the same conclusion. All right. So that was a lot of information. So if something's unclear, you probably want to watch a few times. It's worth the effort because we're going to be using this again next week. So if you understand this week, next week will be a lot easier. Next module will be a lot easier. Okay. So to help you get through the assignment, if you look at in my Google Docs, I gave you the answers to a few problems. Okay, not all of them, but a few of these. So make sure your answers match what's in my partial solution key here. Okay, if not, and if you cannot figure out how to do these, get to the right numbers, email me your spreadsheet and I'll take a look. Okay, so for this module to get full credit, you have to show me how you get the numbers. If you just say number 3 answer is negative 1.48675, you will not get credit for it. Okay, so just FYI. Okay, now recommend you read part 1 and part 2 of the PDF. Okay, and you should be able to do the quiz with the help with the spreadsheet. And after you've done all that, you should be able to do the course project phase 3, because phase 3 is about hypothesis testing. Okay, so make sure you understand the hypothesis testing before you attempt to do the course project. And if you have any questions in the meantime, just email me and I'll help you out. You probably have questions because it's a lot of information. So, but once you get the hang of it, it's not too bad. So let me know if you have any questions, and I'll talk to you next week.